Okay, our first example, it says at what time on the interval from 0 to 12 is the volume of heating oil in the tank the least? So we want to find the minimum amount of oil in the tank. So it does say that when you begin, you start with 125 gallons of heating oil in the tank. So our amount function is going to start with 125. It says that H of T is the amount of heating oil pumped into the tank. So that's the rate going in. And then we got to do minus, and then R of T is the rate that the heating oil is being removed from the tank. So we're going to do minus R. So this is your amount function. And again, we're looking for the time when the amount is the least. So we want to minimize that function. So the way we find the minimum is we do the derivative. So here's our derivative. We set our derivative equal to 0. And if we do that with our graphing calculator, we're going to get these two critical numbers. Remember, we are just looking on the time interval from 0 to 12. If you don't evaluate it on that time interval, you can see this is a periodic function, so you may get an infinite number of answers. So we just want to find the answers from 0 to 12. Now, these are going to be our critical numbers, so if there's going to be a minimum, it would have to either happen at one of those two spots, or it could happen at one of the two endpoints. So you do want to check the endpoints, 0 and 12, because we're dealing with a closed interval, so we need to do the closed interval test. Now, after we plug in the endpoints and our two critical numbers, we can just look at the y values and see how big they are. We can see that the maximum amount happens when the time is equal to A, which is 4.790 hours. The minimum occurs at time B, which is 11.318 hours. That minimum amount is 120.738. You always want to make sure that you answer the question. The question's asking for the time. So our answer is going to be the B value, not the actual minimum amount. So our B value was 11.318 hours. Now I do want to say that a lot of this is done with the graphing calculator. So what I'll usually do is I'll plug these functions into y1 or sometimes y1 and y2, and then I'll solve where it's equal to 0, and I'll evaluate it when t is greater than or equal to 0 and when t is less than or equal to 12. And it will give you these values. Those are decimals, so you usually want to push green enter with the TI-89 graphing calculator. All right, let's take a look at the next question. For this example, they want to know what time, so again, our answer is going to be time, is the line for the ride the longest. So we want to find the maximum amount of people in line. So it does say that we start with 700 people, so that's going to be our starting amount. And then we want to add all of our changes, but there is a rate going in, that's R of T, and then we want to do minus, and then there's a constant rate going out. So 800 people are constantly going out per hour. Again, we want to maximize this function, so we want to do the derivative, and then we would just get R of T minus 800. Then we want to set our derivative equal to 0. And since we have this graph here, there's actually a fast way of doing this. R of T minus 800 will equal 0 when R of T is equal to 800. You can see this dotted line that says out is the rate that people get out of line, and that's because they're getting onto the ride. The blue line is the rate that people get in line. We can clearly see that R of T is going to equal 800 at this point right here, and that's when the time is equal to 3 hours. So that's kind of like our critical number. So our critical number is T equals 3 hours. We could also check the endpoints, which would be 0 and 8, except it's a little bit easier than that. We can clearly see that there are more people getting in line compared to the amount of people getting out of line all the way until that moment in time. So if there are more people getting in line, then that means the amount is going to be increasing until that time. So we know our amount function is going to be increasing until t equals 3. Then you can see afterwards there are more people getting out compared to the amount of people getting in. So then that means the amount function would be decreasing afterwards, and you can clearly see that we would have a max at that time. So when t equals 3, there would be a maximum number of people in line. Now, one way you could write that to justify your answer is you could say that a prime of t is greater than 0. And then on this side, I'm going to say that a prime of t is less than 0. And so that's a way of justifying your answer. If your derivative is greater than 0, then that means your original function would be increasing. And over here, I'm saying my derivative is less than 0. So my amount function would be decreasing. And so this point right here, when t is equal to 3, would be your maximum value for the amount function. So that's when there's a maximum amount of people in line. It'd be at the moment when t is equal to 3 hours. Now this is kind of like a part B to the same question. They say now that we know that the time is 3 hours, how many people are in line at that moment in time? We're going to start with our amount function, but we want to find the amount when t is 3. So we're going to plug a 3 into our amount function. That's going to give us 700 plus, so we have the 700 and then the plus. And then we're going to do the integral from 0 to 3 of r of x minus 800. So the 700 is easy, we just copy the 700. The 800 is even easy. If we wanted to do the integral from 0 to 3 of 800, it's kind of like the area under the curve over here from 0 to 3 and underneath 800. That's just a rectangle, so it's just going to be 3 times 800, and that's where I'm getting 2400 from. So it looks like the only hard part would be the integral from 0 to 3 of r of x. Now that would be the area under the curve over here from 0 to 3. So it'd be the area of that shaded region right there. And I'm actually breaking it into 2 pieces. So here are the 2 pieces here. They are both trapezoids. So we're going to do the area of a trapezoid. The area of a trapezoid is going to be the width times the average height. So the height here is 1000 and the height here is 1200. So we need to add up those 2 heights and divide by 2, and that'll give us our average height. For the second trapezoid, that'd be this shaded region right here. This is our second trapezoid. The area of that trapezoid would be the width, which is just 1, and then times the average height. So the height over here is 1200, and the height down here is 800. So we got to add them up and divide by 2. That'll give you the average height. So this is 1100 times 2. So that's giving us 2200. And then plus, and this would be 2000 divided by 2. So that'd be 1000. And so that's how I'm getting the 3200. That's the hardest part. And if you add up all these numbers here, you're going to get 1500. So when t is 3 hours, the amount of people waiting in line is exactly 1500 people. All right, here's our last example. We have a function over here that they're calling f of t, and f of t is this entire function over here. Now, in the description, it does say that f of t is equal to this cubic function, but that's just on the interval from 0 to 4. So this f function that they're describing right here is just from 0 to 4. So that's this part of the graph right here. The rest of it is made up of just lines. But f is actually the entire function, not just this cubic part right here. So this cubic part is just the beginning from t equals 0 to t equals 4. So when we do the derivative over here, we're just looking at the beginning section here from 0 to 4. It's not the entire piece. So I just wanted to clarify that before we moved on. But the question here wants to know, when is f increasing the most? So this is going to be one of those tricky ones. If they just want to know where f is increasing, well, that's easy. You just look at the derivative, and anywhere your derivative is positive, well, that's where f is increasing. We could also just look at the graph. We can see it's the brown portions. I made them brown on purpose just so they'll stand out. That's where f is increasing. But we want to know where f is increasing the most. So we need to do one more derivative. And the reason why is because this function finds the max of the one before it. The one before it tells us where the original function was increasing or decreasing. So f double prime is going to find out the most of that, the max or min of that. So we got to do the second derivative, and then we got to set it equal to 0. So that's actually a pretty easy one. If you set this equal to 0, you're going to get 2. I think you can clearly see if you put a 2 in here, it'll cancel with a 2 on the bottom, and you'll just be left with -3 plus 3. So you can see that when you plug in a 2, you do get 0. So that's a really, really easy one. But that's going to be kind of like your critical number. When t is equal to 2 minutes, that's this spot right here, that's going to be a critical number, and that'll tell us about f prime. It's going to be a max or min for f prime. So we already know that f is increasing on that interval, but now this tells us that there's going to be a max or min at that spot for f prime. So the slope is either going to be a biggest slope or a smallest slope at that spot. When I say slope, I'm talking about this function here. This function is the slope of f. So this is a very, very tricky one. Again, just to try to explain what we're doing here, this f prime function will tell us where f is either increasing or decreasing. We are looking for where f is increasing, but we want to find where it's increasing the most. So that's why we have to look at one more derivative, and that will tell us the most of that thing before it. It'll find the max and also the min of the thing before it. So it turns out we're getting either a max or min when t is 2. So we want to find out, well, what is the slope then when t is 2? So we need to plug in a 2. And if we plug in the 2, we're getting a slope of 3. So that's how much f is increasing at time t equals 2. At that point right here, f is increasing at this rate, 3 calories per minute squared. Now let me talk real quick about the units. The units for your f function were calories per minute. It says it right here, calories per minute. So the derivative, which is our f prime, would have units of calories per minute squared. You get one more unit of time on the bottom. So just to clarify that part. Now we also might want to check these two endpoints to see what the slope is at those two spots. So you could plug in a 4 if you wanted to, and you could also plug in a 0. Plugging in a 0 just gives you 0, so that's not bigger than 3. If you plug in a 4, you're also getting 0, so that's not very big. But one of the things I wanted to point out was you actually don't have to check those two endpoints. And that's because this point right here is actually an inflection point. It was where our second derivative was 0. It was an inflection point. You can even see it with your eyes. It looks like it's increasing concave up and then increasing concave down, and it changes at that point. That's kind of what's happening over here. If you were to zoom in a lot more, it would look something like this. So the steepest slope would happen at that spot right there. The slope is 3. It's not going to be a vertical line, but it's going to look almost vertical. So that's the slope here. The only other possible spot where the slope could be steeper maybe is over here. And we can just count that one. We're at 9 and we go up to 15. So that means we went up 6. And then we're going to go right 4. So we went up 6 and right 4. So if we go up 6 and we go right 4, that's a slope of 3 halves. And 3 halves is the same thing as 1.5. So the slope over here is 1.5. So which one is steeper, the 3 or the 1.5? Well, of course it's the 3. So that's going to be our final answer. They wanted to know what time is f increasing the most. Well, it's at this time, 2 minutes. When t is 2 minutes, f is increasing at this rate, 3 calories per minute squared. So t is equal to 2 minutes. It's going to be our final answer. And that's pretty tricky. That's going to be one of the toughest ones. And I've actually talked to one of the AP graders, and they actually told me that this question wouldn't even show up on the AP test. When something is increasing the most, or when something is decreasing the most. I'm not sure that I believe him, so I still want to make sure we know how to do this kind of question.